Hello everyone, my name is Navid Afridi. Today in this video I am going to tell you a fluid mechanics unit, that is major and the minor losses. Today we are going to be discuss about major and the minor losses in the fluid mechanics. Major and minor losses in fluid mechanics. This is a very important chapter for your gate purpose also. Fluid mechanics. This comes under closed conduit pipe or flow through the pipe. First of all, let me tell you what is the definition of the pipe. A pipe is defined as a passage with a closed parameters in which the fluid flows under the pressure. A pipe is nothing but you can say it is a closed parameter in which fluid flows. That is nothing but the definition of pipe. Now, what are the losses that you are going to be see in the fluid mechanics? First, there are two types of losses, that is major losses, and second one is minor losses. Okay, you have seen that you have seen in the case of what I can say, when the fluid passes through a pipe, it energy losses takes place. The various losses are nothing but major and the minor losses. We have in the case of minor losses we have HF. uh, HF is nothing but head of loss due to the frictions, and in the case of minor losses we have different, then that is 5 or 6 types. And then we are going to be tell you about the how to first derivation of major losses. Why we are differentiating between major and the minor losses means, the long pipe. What is the meaning of the long pipe? Long pipe means if the diameter of the pipe, if the diameter of the pipe diameter of the pipe if the diameter of the pipe, or I can say the length of the pipe, if the length of the pipe is greater than 200 times of diameter of the pipe, diameter of the pipe, then that pipe is that is considered as long pipe. Somebody asks you what is the meaning of the long pipe, please remember this one. The length of the pipe greater than 200 times of the diameter of the pipe, that pipe is considered as long pipe. Why we are differentiating the friction law as a major loss means, in the case of the long pipe, the energy loss takes place due to the friction only. The major loss of energy takes place due to the friction. So we are considering friction loss as major loss. Now derivation of derivation of major loss, that is HF. According to the Bernoulli's equation, we have Bernoulli's equation. Bernoulli's equation says Z1 plus P1 by rho g plus V1 square by 2g is equals to Z2 plus P2 by 2g plus V2 square by 2g. We are considering two sections of the pipe as shown in the figure. You can see in the figure, this is the pipe, this is the entrance section of the pipe, and this is the exit section of the pipe, you can see as here, and this is the connection to the pipe. We can say this is the section 1, this is section 2, and this is the length L, and this is the entrance, and this is the exit section of the pipe. And datum line, this is Z1, you have seen in the Bernoulli's equation, and this is Z2. And then what we have, this is datum line, this is the datum line. So we are considering the two section. For the first section, Z1 plus P1 by rho g plus V1 square by 2g is equals to Z2 plus P2 by rho g plus V2 square by 2g. According to the Bernoulli's equation for the section 1 and the section 2, we have written the Bernoulli's equation. In this case, what we can write here, because it is horizontal, we have Z1 is equals to Z2, and velocity is constant throughout the flow. So V1 is equals to V2. What I can write, this is P1 by rho g, this p1 by rho g, and this p2 is there, no, it will come this side. This is p2 by rho g, p2 by rho g, that's equals to, I have forgotten here, plus hf. This is, there is a loss of energy is taken place low, then this is hf. What I can write, hf is equals to p1 by rho g, p2 by rho g is equals to hf. Take this as equation number 1. If you want the whole derivation, please watch my next video. Thank you.